All right, Algebra 2 students, we're going to be doing some reviewing on some graphs that we have previously studied. And those are linear functions, which are first degree, and obviously are a line, quadratic equations, which are second degree, second power of x, and those are parabolas, either opening up or down, absolute value, which are v's, and then the square root function, which is kind of a sideways parabola, just the top or the bottom half of that. So I'm going to do a few examples of each of these, and then you'll have an assignment to do to show your understanding. So the first one is y equals 2x minus 3. So this is a line. It's first degree. It's in slope-intercept form. So negative 3 is your y-intercept. Your slope is 2. You'd go up 2 and over 1, up 2 and over 1, and then you would draw your line. Positive slope, the line's going up. The blue one is also in slope-intercept form. Its y-intercept is a positive 2, and we would go up 2 and over 3, or you could go down 2 and left 3.
Today we're going to learn about the other trig functions.
And you've got your line again with a positive slope there. The one in green is in standard form, and if you remember here we found our intercept, so to find the x-intercept you'd cover up the y term, and x-intercept would be 2. To find your y-intercept you'd cover up the x term, and your y-intercept would be 3, and then you would draw your line. The last example is one variable, so if it's just x equals a number, that's a vertical line through 3. And then you would imagine that if it's y equals, then it would be a horizontal line. Quadratics, so remember quadratics, they have to have an x squared in them. They are parabolas, and our basic movement is over 1 up 1, over 1 up 3, over 1 up 5, times the a value, dependent on that. So this first couple here are in what's called vertex form. So in the red one, we could move to the right 1 and up 3. And then we would double the y values. So it would be over 1 up 2, and then over 1 up 6, and your parabola would look like this. The blue one's also vertex form. It's left 2. There is no up or down movement, so it is just left 2. And then we would go over 1 and down 3. Over 1 and down 3. Your next one would be over 1 down 9. So that'd be way off the graph, and it would look something like this. The green graph is a parabola in standard form. There's no b term. The c is negative 4, so that means your y-intercept is negative 4. It also means that the parabola's moved down 4. And then your standard movement of over 1 up 1, over 1 up 3 gives you your parabola. The yellow one is in standard form. To find the vertex of this, remember you could change the vertex form, or the x-coordinates negative b over 2a, which in this case would be 2 over 2 or 1. If I plug 1 into the equation, 1 squared is 1, minus 2 is minus 1, plus 3 is 2. So my vertex would be 1, 2. A is 1, so I'd go over 1 up 1. I'd also know my c value is my y-intercept. So that also makes sense. And there's my graph. Absolute value graphs, remember these are v's. And our movement in an absolute value is over 1 up 1, over 1 up 1, over 1 up 1. So this one in red, you can see we'll move 1 to the right and up 4. And then we'll go over 1 up 2. And then over 1 up 2 again. So these are straight lines. It's not curved. It is a straight V. The one in blue is not moved left to right at all, but it's moved up 2. And it's over 1 down 3. And over 1 down 3. opening downward. The green one is not moved left or right. It's not moved up or down. It is right at the origin. And then it's over 1, up 4. So stretched vertically there by 4 times. Very skinny looking V. And then the yellow graph is moved right 1 and up 4. Right 1 and up 4, which was about right there. And then this one's kind of unique. It's vertically stretched, so I'm going to multiply my y's by -3. And then on the inside, I'm dividing by 2. So I do the opposite. I multiply the x's by 2. So from this point, I'm going to go over 2, and I'm going to go down 3. Over 2, down 3. You can see how it stretches it horizontally, and it's also stretched vertically and flipped. And the last one, most familiar to you, are the square root graphs. Remember, those graphs are kind of a sideways looking parabola where we go over 1 up 1, over 3 up 1, over 5 up 1. And so this red graph is moved right 3. Not up or down at all, it's not stretched. So then just over 1 up 1, over 3 up 1, and we get that square root graph. Remember we talked about domain and range of those? Blue graph, we move left 1 up 4, and then I would go over 1 up 2, and then over 3 up 2, and my graph would look like this. The green graph's not moved left to right at all, it's moved up 2, and then I would go over 1, down 3, and then over 3, down 3, and my graph would look like that. The fourth one there, the one in yellow, is a horizontal stretched one, so this is moved right 2, and then that dividing by 3 on the inside is going to multiply these by 3. Horizontally stretching it. So from there I would go over 3 and up 1. Oops, wrong way. Over 3 and up 1. And then over 9 and up 1. So it really flattens this out. Horizontally stretches it. Okay, you have an assignment there. You have 2 parts to the assignment. There's 6 graphs on each one. You should be able to graph these very quickly. If it's taking you quite a while to graph one, you're probably using the wrong process. Hope this helps. Have a great distance learning day.